Okay, so I'm going to be reviewing fractions and the different forms that they are shown in. So the first thing that I would suggest is that you just learn fractions, learn to recognize certain fractions in their decimal equivalent. For instance, 1 over 4, 2 over 4, 3 over 4, 4 over 4. And the way that I typically tell students to remember how to find the decimal equivalent to that is to think of money. So 4 quarters represent one whole dollar. So if I'm going backwards from what I just highlighted and I go over here, so 4 quarters out of 4 quarters equals exactly $1, which is one. Now, if I wanted to, I could go ahead and add the 0.00 to show it in the form of a dollar, but it's not necessary. In terms of now, if I was asked to round it to the nearest tenths, and that's with th on the end, so tenths, then I would stop at point one place after the decimal. If I was asked to round it to the nearest hundredths, and again, I am emphasizing the THS on the end, that would mean I'm going 2 places after the decimal. But I don't typically have to do that if I have a fraction that has the same numerator and the same denominator, as in this case, same numerator, which is the number on top, and the same denominator, the number that's on bottom. If they're the same, my answer will always be 1. So 1 quarter out of 4 quarters, or out of a dollar, this is how a quarter is represented as a decimal, 0.25. Some people actually put a 0 in front of it, which is fine as well. So 0.25 means the exact same thing as 0.25. Sometimes I'm lazy, I forget to put the 0 part. Now, if I'm looking at 2/4, that means the same thing as 2 quarters out of 4. So what is that? That's 50 cent. 50 cent as a decimal is represented as 0.50. And if we were to simplify 2/4, then that really is 1/2. We'll talk about that in a few minutes, how you can see what two equivalent fractions are, how you can test it. Okay, and then if I go on to 3/4, or sometimes people say it as 3 quarters, it means the same thing. So 1 quarter, 1/4, same thing. So 3 out of 4 is 75 cent if you're thinking money. 75 cent represented as a decimal is 0.75 or 0.75. And we already talked about the one whole. Another fraction that you commonly see is 1 over 3, and that is equivalent to 0.33 repeating. So this little symbol here, if you ever see that, that means that the 3 just keeps repeating over and over and over. So instead of writing 0.333333 forever, then you can just put the little line over it. Now, if 1 over 3 is 0.33, and now all I did was change this, I still have 3 as my denominator, but I went to 2 over 3, then what I could do is just either take 2 and multiply it times 0.33, which will result in 0.66, or I can just add 0.33 2 times. So if I did now, this is the tricky part because some people will try to take that method and apply it here. But I just told you if you have the same numerator and the same denominator, your answer will be 1. So, but if you were to try to take the 0.33 and multiply it times 3 this time, you're going to get 0.99 repeating, which of course, if you round it is 1, but don't get that part in your head. Anytime you have a numerator and denominator that are exactly the same, your answer is what? You're right, 1. So those are the fractions you should just memorize. So if you just automatically see 1/4, you should know, oh, okay, that just means 0.25 because it's the same as 1/4. So various representations of a fraction. You don't really think about this, but all real numbers are fractions. So let me just give you some examples. So if I'm writing my numbers down here, 1, 2, 3, 4. This is how we count. But all of those numbers are actually fractions. How? I just put a 1 under it. So this is really 1 over 1, 2 over 1, 3 over 1, and 4 over 1. Do you want to count like that? Count to 4. 1 over 1, 2 over 1, 3 over 1, 4 over 1. No, you don't want to count like that. So it's simply 1, 2, 3, 4. And if you were asked to put 1, 2, 3, 4 in decimal form, it's simply 1. Well, any whole number has the decimal after it, and it's followed by 0. So 1.0, 2.0, 3.0, 4.0. So again, if you were counting, do you literally want to count like that? 1.0, 2.0? No, you don't. But just know all real numbers are actually fractions and they can be decimals as well. So in elementary school, you're typically taught to use your number line. So you might try to figure out, well, how can I make a fraction if all I'm given is 0 and 1? Well, what you would want to do is count your tick marks. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, that tells me what my denominator is going to be because my denominator is my total. So I know I'm going to have 8. I told you anytime you have the same numerator and the denominator, it's going to be 1. So I know that 1 is really 8 out of 8. So now all I have to do is just fill in the other tick marks. So if you didn't guess, tick marks, what I'm talking about are the little dashes that are coming from the number line. So I have 1 out of 8, 2 out of 8, 3 out of 8, 4 out of 8. And you just keep counting until you get to your 8 out of 8. For this example, now all of them may not have the same amount of tick marks, so you have to pay attention to that as well. Now, you can find some equivalent fractions here. So if I look at 2 out of 8, I understand that if I were to simplify or reduce that, then that becomes 1 over 4. So above that, 1 over 4 is equivalent. I'm actually going to leave some space here. Let me see. 1 over 4 is equivalent to 2 over 8. Well, if I go down some more, I see 4 over 8. I can simplify that one as well. And if I simplify that, that is going to be 1/2. And then if I go over even more, I have a pattern. You see, I'm kind of skipping one, and then I can simplify the next one, which is 6 out of 8. And when I simplify that, I end up with 3 out of 4. And if I skip another tick mark and I go to the next one, well, that's really 4 out of 4. Now, you might say here, well, that one ends up with a 2 in my denominator and everything else has a 4 in the denominator. But recall from earlier, this is really 2 out of 4. And 2 out of 4 is actually 1/2. So that's how you can look at that. So let me show you what I was saying. Well, let me go ahead and, so if I were drawing this as a separate number line, my tick marks will be spaced out differently. And here I could say 0 out of 4, which is 0. And then below I could have said 0 out of 8. 0 divided by 8 is 0, and so is 0 divided by 4, still 0. The only difference is the tick mark. So on the orange one, I'm going from 1, 2, 3, 4. So I know that at the end, where this is 1, it's going to be the same numerator and the same denominator. I already know that. So what I was saying a few minutes ago, as far as trying to figure out if a fraction is equivalent, what you can do is, I'm saying that these two are equivalent. This is just one that I just chose. So I can take 4/8 and I can set it equal to, well, I can do it two ways. Well, the one way that I'm going to do it is I'm looking for a greatest common factor between the numerator and the denominator. What can I do? I can divide both of those by 4. That's the greatest common denominator. I could have divided it by 2, and I'll show you that as well. So if I divided it by 2, I'm going to end up with 4 divided by 2 is 2, 8 divided by 2 is 4. Well, I can simplify this further. So that's why I want the greatest common factor. What is the biggest number I can divide both of those numbers by? You always want to try the smallest number that's given to you. So out of 4 and 8, 4 is the smallest number. So you always want to try that number first. So when you do that, 4 divided by 4, any number divided by itself is what again? 1. You're right. 8 divided by 4 is 2. So the simplified version of 4 over 8 is 1/2. If I still want to check it even further, what I can do is cross multiply. 8 times 1 is 8. 4 times 2 is 8. So 8 does in fact equal 8. So therefore they are equivalent. So another way that you may be asked is to look at the fractions and try to order them from least to greatest. There's different ways that you can do this. You can, if you're a visual person, you can actually draw it out. So that's what some people do. They will take, we're used to using circles, and let's see, the total is, for this fraction, 8. So I'm going to have 8 equal parts. Now my drawing is going to be off a little because I'm just trying to freehand this. All right, so I have 8 equal parts, and out of those 8 equal parts, I only want 5 of them. So if I am trying to do that, then I know I'm going to shade in half plus 1, because half was 4. 4 is half of 8, and that's what I'm left with. That's for 5/8. If I'm looking for the next one, now this is odd because I see that my denominator is simply 1, but my numerator is 3. So what I would do is just have, okay, there's 1, there's 2, and there's another one. So I was told that I am going to shade in, if I'm using a visual representation, 3 out of each one. So that's what that looks like. And then the next one is going to be 2 out of 4. So I'm going to divide this into 4 equal parts, and I only want to shade 2 portions of that, which, guess what? If you look at it, it's exactly 1/2, right? So I can look at it and I can see that this is 1/2, which, if you memorize the decimal form of this, 1/2 is the same as 0.5, or again, 0.5 if that's how you want to write it, or 0.50. It means the same. If you have a 0 afterwards, you don't have to add that 0 unless you just want to. This, the middle one, is simply 3. All 3 are shaded. So 3.0 if you wanted it in the form of a decimal. And then for the first one, I'm working backwards. 3 of the parts were left unshaded. So the way that you can try to figure this one out, if you were looking at it in terms of a decimal, is the top dog. This is a saying, top dog goes in the house. Remember, fractions simply mean dividing. So the top dog is 5. 5 goes in the house, and I'm dividing it by 8. Well, let's think about this. I have 8 people, and I have 5 candy bars. I want to divide those 5 candy bars evenly, or close to evenly as possible, into 8 people. Can I do that? Of course I cannot. If the number inside of your house is smaller than what's on the outside, that means you're going to add a decimal. And when you add a decimal, you have to also add the 0, and you also have to align the decimals above. So this is the only 2 times you're going to add the decimal. You're going to add it under the house and right above. You have to line it up. 2 ways to look at this. You can now look at it as 50. Don't try to look at it as 5.0 because that's going to throw you off. 50 divided by 8, or 8 times what will give me 50 or close to 50. So knowing your multiplication facts will really help. So 8 times 6 is 48. So I'm going to take that 48 and I'm going to put it below. Again, I'm not putting a decimal there. I'm just putting 48. Once I subtract, I'm going to bring down 10 minus 8 is going to be 2. Well, I can't take 2 items and divide it by 8. So again, I'm going to add another 0, bring that down. So again, I can say 20 divided by 8, or 8 times what will get me close to 20? 8 times 2. So 8 times 2 is 16. I'm going to continue the process of subtracting. 10 minus 6 is going to give me 4. I can't take 4 items and divide it into 8 things. So I'm going to, again, add a 0, bring it down. 40 divided by 8, or 8 times what will get me 40 or close to 40? Well, we should know that it's 5. So now I have a zero remainder, which means that 5.5 over 8 is the equivalent of 0.625. 3 over 1 is simply 3. If you wanted to put the decimal again, it's 0.0. So any number over 1 is simply itself. So don't forget that rule. Any number over itself is itself. Any number over itself is 1. Don't get those confused. All right, and then 2 over 4 is equivalent to 1/2, which is 0.5 as a decimal. So 0.5, so that I don't confuse people, let's just do that. Now, the directions ask me to order these fractions from least to greatest. So if I am looking at this, I can see that my smallest fraction is, and this is another part that throws people off. So again, let me just put the point here actually so you can see. If there is a number before the decimal, that is definitely going to be a bigger number than what's shown as 0, because 3 is bigger than 0 in this case, right? So we know 3 is definitely going to be our last fraction. That's the greatest fraction. So we can go ahead and put that in last place. Now, some people, when they're trying to determine which decimal is larger, they look at how many numbers are shown after the decimal versus what number comes after the decimal. So the amount of numbers shown after the decimal does not matter. So what you're looking at is what's in the tens place. Which number is bigger, 5 or 6? 6 is bigger. So since we're going from least to greatest, that means that we're going to put 2/4 first, and then 5 over 8, and we already said 3.0. And you're going to say, well, there's a 0.0 here. Yes, there is. But again, there's also a number in front, which represents, think of it as money. If I were to put another 0 here, this is $3 versus this being 50 cents versus this being 62.5. Well, we'll round it to 63 cents. Which one is the smallest and which one is the largest? So that's how decimals work when you're trying to compare them, put them in a different form. That's how fractions work when you're putting them in decimal form. Okay, so those are different visuals. You can, again, line it up on a number line if you needed to. Let's see here. Ratios. Well, fractions are ratios, so let's just use those same examples. If I were to use 5 over 8, as a ratio, you would see that it's 5 to 8. If I said 8 to 5, the first number is my numerator, so it's really 8 over 5. And whatever my second number is, that's my denominator. So make sure you understand that. 3 to 1 is simply 3 over 1. 1 to 3 is 1 over 3. So see, it means the same things. It's equivalent, it's just in a different form. And then this is my last portion that I want to discuss. And that is if you are asked to write 2 equivalent fractions and you are given this information. Well, this is a whole number that you're trying to make equivalent fractions from. Well, remember, all real numbers are fractions. So this 2 would actually become 2 over 1. If I'm using this method, you don't have to. 2 times 4 is what? 8. So therefore, I know what's going to go in this box is 8, because 8 times 1 is 8, and 2 times 4 is 8. That's one way. If you don't want to change that to a fraction, then you would just ask yourself, what can I put here and divide by 4 to end up with 2? Okay? It's whatever way is easiest for you. Now this next one, you can do the same thing. You can say 2 over 1, and then you can try to just ignore this middle fraction for now and cross multiply. 2 times 6 is 12. So therefore, 1 times what is also 12? Yep, 12. So all 3 of these are equivalent. 4 times 12 is 48. 8 times 6 is 48. And I already showed you the 2 and the 6 and the 1 and the 12. So this next one, again, you don't have to do it the way that I just did it. What divided by 3 would result in 6? So if you understand inverses, it's going to be 3 times what to give you that answer. So that's how you get that information. So that's going to be 18. And now if I wanted to figure out this next blank space, I can just cross multiply, or the easiest way I think is to look at the first one, because again, all 3 of these are equivalent. So since 18 over 3 might seem like a big number to you, let's just work with this. Let's work with those 2 fractions. And if I did that, 6 over 1, and I am trying to take 1, excuse me, I don't know what just happened here. Okay, so 1 times 24 is 24. 6 times what is 24? And that's one way that you can figure it out. And that will be 4. And if you just really, really wanted to double check it, you can just do your math here. You can say 18 times 4 is going to be 72. And does 24 times 3 also equal 72? Yes, it does. So to summarize, your fractions can come in different forms, and every real number is a fraction. It's also a decimal. And your numerator, if it's smaller than your denominator, so your numerator is smaller than your denominator, then that means when you are writing it in decimal form, the 0 comes before the decimal. If your numerator is larger, then let's go to an example here. If your numerator is larger than your denominator, that means that the number comes first and then the decimal. So keep those rules in mind. I know this was a super long video. And also your whole number does not have to have a decimal. So 3.3 does not have to be written as 3.3. It's a whole number, so you can just write it as 3. It's understood to mean the same thing. Okay, hope this helped you with recalling what you learned about fractions. Have a great day.